With O9, you can improve accuracy and reduce the time spent in forecasting. So how do we make this happen? It is through a combination of workflow, data, and technology. All these three elements can be brought together in the O9 digital brain. The digital brain converts data into knowledge by connecting large amounts of discrete data using nodes and edges to build the Enterprise Knowledge Graph, or EKG. O9 machine learning uses this knowledge based on lagging and leading indicators to make better predictions. O9 also highlights actionable exceptions for planners to make faster and more insightful decisions. Let's look at some examples of O9's intelligent predictions and insight based on internal and external driver data. Firstly, let's look at holidays. Easter is a typical challenge because it moves from one year to the next. Easter falls on the first Sunday after the spring equinox full moon. For example, in 2019, Easter was in week 17, and in 2020, it was week 16. Forecasting seasonal products against movable annual holidays like this is problematic for traditional time series methods. Here's an example where we see the sales of some seasonal products. Notice the distinctive repeated shape. If we overlay Easter holiday, the seasonal correlation becomes clear. The O9 digital brain learns that the Easter spike buy-in is always 14 weeks prior to the holiday and uses this insight to build the forecast. Holidays can significantly contribute to demand, and this seasonal insight will help prepare for the Easter sales surge and remove any surprises. Now let's look at list price. Here we can see that the sales dropped significantly for this product in the month of September. Bringing in the list price into the picture shows that the drop in sales was tied very closely to the price hike in the same month. The O9 digital brain learns from this feature and uses this relationship to predict a drop in volume for the next price increase planned in 2021. Including historical prices and expected price changes can improve forecast prediction and minimize excess build. Now let us consider the impact of short shipments or cut quantities. This example shows shipment history with a crazy volatility. If we load the cut quantity data, you can clearly see the missed shipments that were due to supply challenges. Simply adding the cut quantity to shipments will overinflate the demand because customers reorder the same quantity if the original order is not met. O9's digital brain can correct the history by using a more sophisticated algorithm such as seasonally adjusted linear interpolation to reflect the true demand. This corrected shipment history can then be used as an input for forecasting. This last example examines the impact of COVID in history data. Here, we see product sales for impulse items up to 2021. Overlaying the prior year shows a reduction in volume in 2020 versus 2019. Even though the year started off strong, there was a distinct drop from March. This can be attributed to items not being bought due to COVID restrictions. There was simply less footfall in stores. Adjusting volumes for 2020 will give a better prediction for the future because the same restrictions are not expected to be in place. As you can see from these examples, the O9 digital brain with machine learning prediction can dramatically improve forecast accuracy, provide actionable insights, and significantly reduce the time spent in the forecast consensus process.